Hello and welcome to Datamura Solutions online learning series. Today is Wednesday, December 8th, 2021. We'll be discussing and demonstrating a process to maintain and manage engineering change requests. My name is Bill Thompson, and I'll be facilitating today's session. A few housekeeping items before we start. One, our session is being recorded. Number two, all registrants will receive a link to the webinar recording. Most importantly, number three, this session is live. We're really encouraging participation. We will be addressing each question or comment received in a live manner this afternoon after we finish up with the presentation material. To submit questions, please use the GoToWebinar panel. There's a questions tab. If you enter there, we will address it at the conclusion of our prepared remarks. Today, we're continuing in our digitalization of asset management through our online learning series on an engineering change request process. We will look into the hows and whys of the change management process through a facilities perspective. To help with this educational session, we have asked a project team member to discuss and demonstrate these findings and results. Mr. Joey Davis is a degreed mechanical engineer from the University of Maryland in Baltimore County. He jumped at the chance to showcase his work on the topic. It's my pleasure to introduce Mr. Joey Davis. Joey, the floor is yours. Thank you.
I'm a project engineer for Datamura Solutions, and today I'd like to talk about the engineering change management process overall. So we all know that change management can simultaneously be one of the most important, but also one of the most tedious things that we do in our daily jobs. It is extremely important, for example, that if a piece of equipment needs to be changed out for a different one, say a tank, we have to update it to make sure it has the correct data assigned to it. Examples of this data could be the capacity of the tank, the correct electrical information, or even the correct service information. If we don't do that, the next time we have a major change related to that specific asset, we aren't going to have the correct information to base our design off of. You'd think this would be a simple process. However, things like these get missed all of the time. Take a look at this example here. On the right, I have a picture of a pump in the field that clearly shows the manufacturer as one thing, circled in yellow. You can see it says Turner. But if you look to the left, this company's database has it tracked as something completely different. Small differences like these can really add up and make data unusable. Another prime example of missed data is drawings updates. So drawings updates typically come at the end of a project and can oftentimes be neglected. So put yourselves in the shoes of someone working on a project. You just finished, you get your turnover package in full of drawings from the vendor, and you say, okay, my part for the project's done, time to move on. Except, what happens to those drawings? Most times, they're either sitting on somebody's desk collecting dust, or if we're lucky, they're on somebody's desktop. Very rarely do we see them ending up in an organized structure and making their way back into an official set where all the changes are captured and the drawings can be updated to their current field conditions. At the end of the day, next time we need any information that's important, it's out of date, we don't know what we're doing, and we could very easily end up with a costly rework because the design said one thing that should have worked based off the information that we had, but that information was incorrect, leading to the changes being incorrect themselves. So what I'm going to show off today is a compilation of tools that we here at Datamura have put together to help ease processes like the ones I've mentioned and make it so that it's very easy to see what needs to change as part of a project and make sure that it actually does get changed. So let's take, for example, that we have a project going on where a new expansion tank is added in one of the facilities, and this expansion tank has shutoff valves assigned to it and a few pressure gauges that are going to want to talk to my BMS. I think everyone here can agree that this is probably a pretty simple change on paper, but that simple change is going to affect so many different things. It's going to affect our drawings because all of those assets are going to have to show up somewhere. It's going to affect our asset list specifically because we're adding assets to it. We could get asset documentation like a warranty letter or an owner's manual, and we're going to want to be able to pull that back up in the future. Eventually, someone's going to have to do maintenance on this tank, and we're going to need to be able to find any of the information that the vendors gave us. So the main solution that we've developed is actually creating a formal process for document change. We call it an engineering drawings change request, or an EDCR. It's called that because we find that the drawings are at the center of most of these changes, and everything can be found through the drawings one way or another. It's an easy way of making sure that we capture everything using the drawings. However, you probably already have processes in place that we can optimize similar to this. So I'm now going to go ahead and switch over to the solution that I've been talking about. So the change management process as a whole typically starts with capital projects of some form. Somebody goes out in the field and they see a need for some kind of improvement, whether that's the tank that we've been talking about being added, or addressing the need to create more office space or add new lab space or whatever improvement is needed. From there, the actual project can be created and the work can be done. Part of an effective change management program is being able to track the details of all approved projects and associate back in time to be able to tell what happened when. The ability to pull up any of these projects and view all of their details is absolutely crucial. When we pop in here, we can see everything that happened in the project. We can view a quick description of the work that's been done, the various project managers who are assigned to it. So if you have any questions, you know who to ask. Even if they don't know the specific answers to your question, they'll know who to ask, considering they're the project manager. You could see where the work's being done, any turnover package documents assigned to it, and various other details. Tracking projects is key to the change management process because the project drives all of the changes. The EDCRs always come from a project of some sort, and all changes we have tie back to this. So when we're tracking the change management process as a whole, the project is the starting point. You input your project, enter all your information, you track all the details, you get the turnover package at your closeout, and once you're done with that, you follow through on your EDCR process. At that point, you can be assured that all of your drawings are updated, you updated all of your documentation accordingly, and your asset register is updated based on your change. And once you've captured all that, you could have confidence that the next time you're looking for information, you've got exactly what's out in the field. The actual changes done to the drawings can also be very easily tracked. So for example, we might have this EDCR here, and as part of that, we have the project that was associated with it, so there's capital funding that was approved. The project brought certain assets online so that we can then list out the following things: which drawings were impacted, what's the actual change that's being done, and what is the actual scope of the change. Now from this, we have an easy way of progressing through the change through its design and construction, and we can then go out and add those changes through an update process and document them accordingly, making sure to gather all of the important necessary information. Once the project is fully completed, someone like a facilities engineer could then go out in the field and verify that the project was completed per the design, and then we have proof that we have actual as-built field condition documentation. So once that's done, we could then go in and actually update the drawings themselves. So typically, when an EDCR is assigned to a CAD operator, they could come in here, take a look at all this information, look at the drawings that are actually being updated. If they need red lines, they can just come right down here and grab them, and they could see any updates and conversations between members of the EDCR process. This makes it easy to be able to track down information in a matter of a couple of days instead of it taking several weeks or months even to track down simple information. All this is important, but some meaningful value is that this will assist your processes in being FDA compliant in the case of an audit. This entire project now has traceability, and all signatures can be stored electronically. As part of it, it's then very easy to say, okay, now our asset list needs to be updated. The project brought in a couple assets, so we could come in here and add them to our asset list. So once that tank we were talking about, for example, gets added, we could then come in here and view all the details for it. So we have a lot of good information right here. As you can see, just some simple nameplate information. I could then come in here, and if I have any manuals or warranties associated to this tank, I could just toss them right in here. I could populate my warranty letter, a manual, even any maintenance best practices that I may have. Also, any turnover documentation that's provided as part of a project can just be associated straight to the asset. The biggest advantage there is that in 10 years, if I'm ever looking at replacing this specific asset, I have the original documentation right there. I could go back and find any specific information that I may need. So as part of that, I could also come in here and go, okay, this new asset was added, so I could go ahead and do a criticality assessment on it. Doing that, I can make sure I'm doing any preventative maintenance that I may need on this asset. So looking at this overview, if I see that it has high criticality and it's absolutely essential to any of the processes in my plant, I could go, okay, this is a super important piece of equipment. Let's get some monitoring technology on it. And you can see all of that right here and make those assessments just right here. So I could also come in here and say there's new trend points associated with this. Remember the pressure gauges I was talking about earlier? For example, we might want to associate them and come in here and just assign a couple points and view them all in a little graph. That way, if there's ever an operator out in the field, they don't have to go searching or understand the nomenclature of my specific BMS. All they have to do is click on the asset and see it. It could all be stored right here. And that's the power of associating everything together in one spot. You can come in here and see everything as you're going. So another prime example of things that can often get missed as part of the change management process is the actual drawings list themselves. So we talked about earlier, the vendor drawings getting in and being able to update those, but what does that actually turn into? What can that translate to? Well, at the end of the day, what we're trying to get is a list of drawings that represent the facility to an accurate field condition. So what I'm showing here is an example of a list that is up to date. It has all the drawings that are applicable for this specific site, and then you could then search and filter these however you need. This will give you confidence that you're looking at accurate information, which is the key to any change management process. And at the end of it, you should be able to have confidence that the information you're looking at is accurate to field conditions. So when we go ahead and go into one of these drawings, we could just see all the information that we could view here. I could see any past EDCRs done on it. I can navigate to the drawing specific file paths if I need those. I can see where the drawing's located in the facility. I could even see any equipment, instruments, and valves that are associated or show up on the drawing. All this is done because I did my due diligence in my change process and I associated all the correct information to this drawing. This tool set makes it relatively easy to do so, but at the end of the day, associating all of the correct information is key. That way, in the future, it's easy next time we need to make a change. We could save ourselves time and money because we're not hunting all over the place for information that should be easy to access. So now if I go ahead and navigate back to the EDCR I was showing earlier, I could show the power of having a solution like this. So say I'm a CAD operator like before, and this EDCR just got assigned to me. So you could then come in here, view any of the information you'll need for the EDCR. If you needed to contact anyone, all their names are here. I could then view the specific project that this EDCR falls under if I need to know any of that information. I could download any of the turnover package information. I could then go back, see any of the updates currently on the EDCR and see what phase it's currently in. And then if I need to know what drawings are being changed, I could just come in here, look at those, and view their specific pages. I could download them. I could see what equipment is on it. And then from here, I can view the specific equipment and any information I need for that. And if there's any manuals or warranties that I need to view for the equipment, they're all right here. So as you can see, a solution like this could be used to optimize any process any company may have. It is important for all needed data to be easily accessible like I just showed. I navigated through that and all of that important data with a few simple clicks. Thank you for listening. I hope what I showed today is helpful for gaining efficiency in any of your processes. I'm now going to turn it back over to Bill because it looks like he's rejoined.
Joe, thank you so much, and apologize for my technical difficulties earlier. Thank you for picking that up. And thank you for a very thorough overview on the topic. I'll give you a chance to take a breath. It is now time for Q&A. If you have not had a chance to type your question into the panel, to go to webinar panel, please do that now. We do have a number of questions that have been submitted. We'll start with the first one received. Joe, we've got question 1. I would like to understand the steps which should be taken to manage and approve engineering change. Can you help with that?
Yeah, I can. So what I actually showed today was an optimization for a process that's typical for our current solution. So the specific tool set can actually be tailored for any company's specific needs, as long as the company has data and any processes that need optimization. So companies could have different processes for managing their change, but the most important part is optimizing their specific processes, like the EDCR process I showed today.
Great, thank you. We have a second question here. Can you address your comment on mismatched data, specifically as it relates to historic data?
Yes, I can. So oftentimes, historic data could be disorganized or incorrect because the way it was originally taken wasn't comprehensive enough. For example, someone could have walked down a system and missed a valve or missed any piece of equipment that's important, and then that gets added to the database incorrectly and just never gets checked. So the most vital step in any change management process is actually taking that data and ensuring it's correct and coherent. And the tool that I showed today actually assists in all of this.
Great, thank you. Okay. Question 3. Could this process that you demonstrated be replicated outside of your dashboard, i.e. with something like IBM Maximo?
So in short, yes, but the key to what I showed today is actually defining and formalizing a process and then going ahead and optimizing it. So the specific software that it's done under doesn't really matter because we can build a similar tool set in any product, be that Maximo or the custom solution that I showed today.
Okay, great. And for the audience, if the question that you submitted is, if you still have a follow-up to that, you can submit that via the question panel. We can follow up on it here. If we get it in too late, we can follow up in writing following the event. We have a 4th question, Joe. How can you ensure you get a proper turnover package that will give you all the necessary information for as-built conditions in a project?
The question was, how can you ensure that you get the proper turnover package?
I'll repeat it.
Okay, thank you.
Sure. How can you ensure you get a proper turnover package that will give you all the necessary information for as-built conditions in a project?
So a good way for that is to have very good vendor management. So it's extremely important to define what you need or what you're looking for before you start the actual process. So for example, if a vendor is working on something and you know specifically for your process that you need specific information, it is extremely important to put it out there that this is the information I need and make sure that they get that in before you begin the actual change management process.
Great. Thank you, Joe. Okay, we got another question here. What's been your biggest challenge implementing this change management process?
Yeah, so like I've been saying, a big challenge with implementing any process is the data being correct and efficient and like usable. So if the data is unusable or hard to read or incorrect even, it makes the whole process hard to even start. So at the end of the day, it all comes back to making sure the data is correct and usable.
I think you've run into situations where you find data all over the place at some facilities.
Right.
Yeah.
And the first step is always making sure the data is usable and organized.
Usable and organized. Okay, good advice. All right, we have Once we get another question in here, this might be the last one. Joey might be off the hook. In your experience, have you been able to demonstrate efficiency improvements with this type of change management process?
Yes, I have. So oftentimes I actually have to work on EDCRs myself as the CAD operator in my daily job. And before we had a solution like this, the process oftentimes could get stopped at various points because lines of communication were harder to achieve. So at one point in the actual process, it would be stopped and sitting on someone's desk waiting to be signed. And having a solution like this can actually make the process go by much quicker, because instead of needing someone to sign it and then return it to your desk, it's all stored online, and just a few simple clicks accomplishes the same thing as waiting for someone to sign over multiple weeks.
Okay, great. Thank you, Joey. We'll give the audience 30 more seconds if you have any remaining questions or follow-up on what we've been asked or we've covered so far. Actually, we do have one more. Joe, I'll give another couple seconds here. All right. Here's a question. I think it's just for you. Why is it up to project engineers to manage data correctly?
Because in your daily job, if it's your job to manage these processes and the data gets to you, then in order to actually complete the process, the data needs to be correct, it needs to be organized. And if it's missed and unable to be traced down where it was missed, then it just falls on the project engineers.
Okay. Thank you. Okay, we'll give it another 30 seconds or so. Any other new topics or follow-up on what we've covered? Give another about 15 seconds or so before we go on to the next slide. Hey, Joe, can you please clarify, was I cut off before I gave you the introduction?
Yes, you said good morning and then you cut out.
Well, my apologies. I did want to mention, I just want to reference, Joey Davis is a degree mechanical engineer from the University of Maryland, Baltimore County. He's one of our project team members, and he jumped at the chance to showcase his work on this topic today. So, Joe, I wanted to say thank you for what you covered in addressing the Q&A and picking up due to my technical difficulties. So with no further questions and our content done, wanted to cover what's next. We'd like to invite you to join us in February as we continue our online learning series with Design for Reliability, with a focus on commissioning assets. And this is part of our Digitalization of Asset Management online learning series. You can find us on our website, datamura.com. If you're interested, our first two sessions are recorded and available for our online learning library. First covers an outline and process for establishing a digital master asset list for the foundation, and then we explore how you can trend some of the sensor data, create KPIs for energy efficiency and space utilization purposes. That's available on our website, datamura.com, online learning. You can also keep up to date on our latest events, educational webinars and symposiums on our company profile, Datamura Solutions, on LinkedIn. If there are outstanding questions for Datamura or our presenter, Joey Davis, please feel free to reach out to us, info@datamura.com. Be happy to address any outstanding questions that may come up following the session. Lastly, on behalf of Joey Davis and the Datamura team, I'd like to thank you for your attendance. We look forward to speaking with you again in February, and happy holidays.